number 20 on page 416, lesson 8.3, and we're going to do it using the p-value method. A special cable has a breaking strength of 800 pounds. The standard deviation of the population is 12 pounds. Let's write that down. So again, they're giving us the standard deviation of the population. So that tells us right away we can use a z-score instead of a t-score. A researcher selects a sample of 20 cables, so n equals 20, and finds that the average breaking strength is 793 pounds. So that's the average of those 20 cables. So that's your x bar. 793 pounds. Can one reject the claim that the breaking strength is 800 pounds? So they're claiming that the breaking strength is 800 pounds. So let's write our null. They're claiming that the average breaking strength is 800 pounds. That's the claim. So the alternative hypothesis would be that the average breaking strength is not 800 pounds. And when they went out and tested 20 cables, they got 793 pounds. Okay, and I've always wanted to, we may do this experiment, I've always wanted to do it with fishing line. If you buy 8-pound fishing line, does it really break at 8 pounds? Or does it really take a 9-pound fish, or an 8-pound fish, or a 7-pound fish? You know, I think it'd be an interesting experiment to try. But so this is step A. Make sure you identify your claim. Step B is compute the test value. Let's do that next. So test value, you're going to use a formula. We're going to use a z-test. You're going to take your x bar, 793 pounds, minus 800 pounds. What we're doing here is we're trying to get the z-score for 793. We're trying to figure out how many standard errors is 793 from 800. Is it close enough to 800 that we will not reject the null and not reject the claim? Or is it far enough from 800 that we can say the nu is not equal to 800, which means that we would reject the null? Standard deviation is 12 divided by the square root of 20. Anyone know what that comes out to? Top part's going to be negative 7 divided by 12 divided by the square root of 20. Should be a negative answer. Negative 2.61. Okay, others agree? Okay, so that's telling me that 793 is 2.61 standard errors from 800, from the mean. So now we're going to figure out our p-value. So negative 2.61 would be over here. This is our test value. Test value is z equals negative 2.61. Notice we haven't found the critical value, and we're not going to. Now, all you need to do now is go to your z-chart, look up 2.6 and 0.01, and that's going to give you this area right in here. What's that area? 0.4955? Does that sound right?
Yeah.
Okay. So that's this area right in here. The p-value is the area to the left of that test value, or outside of it. So if you subtract 0.5 minus 0.4955, you're always going to have to do that because p-value is always in the tail area. That's going to give you 0.0045. Now we've got to be careful because that's not actually our p-value. It's close, but this is a two-tailed test. So what do I have to do with that number? You got to double it. You also have to consider the area over on the other side is also 0.0045. So our p-value, you only double it when it's a two-tailed test. You take 0.045 times 2, 0.0045 times 2. So our p-value comes out to 0.0090. What that means is that only 90 out of 10,000 times, or you could say 9 out of 1,000 times, would you get an x bar of 793 or more extreme. More extreme meaning further from 800. If 800 is the breaking strength. If 800 is the actual breaking strength of the cable, only 90 out of 10,000 times would you get a value that's at 793 or further away from 800. So it's pretty unlikely. Okay. Now let's look at our alpha. What does it say alpha is in this case? 0.01. Okay, let's put zeros on it so we can compare them. So we look at our alpha here. Which is larger, the alpha or the p-value? Alpha, yep. 100 10,000 is bigger than 90 10,000. So alpha is bigger. Alpha is the area of your critical region. So alpha would be bigger. So that means our critical value, alpha is this purple area here. So our critical values are actually about right in there, even though we didn't actually figure them out. So it looks to me like the test value actually ends up being in the critical region. So should we reject or not reject? Reject, right. When your alpha is larger than your p-value, you're going to reject the null, because that tells you the test value must be in the critical purple region. Okay. So for part D, reject the null. So we look up over here. If we're rejecting the null, that means we think it's false. Okay. So since the claim is the null, we'd also be rejecting the claim. So you'd say there's enough evidence to reject the claim that the average breaking strength is 800 pounds. There's enough evidence to reject the claim that the average breaking strength is 800 pounds. So if the claim is in the null, then you have to use the word reject in both steps D and E. If the claim was in the alternative, you'd use the word reject in step D, but you'd use the word support or not support in step E. Have we proved that it's not 800 pounds? Have we proved it or not? No, we haven't proved it. But we know that the chances, 90 out of 10,000, we would get something like 793 or more extreme. That's not very, if it really is 800, so it looks pretty unlikely that it's 800 pounds. But we haven't really proved it. Any questions? That's good. Okay, so what